Hello students, welcome to the microcontroller embedded system classes. Today we are going to study about the embedded system classification. So what is embedded system? Embedded system is an electromechanical system where it combines of both the hardware and the software, and it is a application specific. Based on the application we are going to develop a system. It's not a general system. Okay, so depending on some criteria, the embedded systems are classified into four categories based on the generation, based on the how system is complex and how it going to perform, and based on the deterministic behavior, and based on the triggering. So based on the generation, again we are having the four generations. In first generation we are going to see about the systems like 8-bit microprocessor and 4-bit microcontroller, and here the systems are with a simple circuit and examples are the digital key. In second generation, the systems are with a 16-bit microprocessor and 8-bit microcontroller. Here you are going to use the powerful instruction sets, and the systems are little bit complicated than the first generations. Examples are data acquisition system. In a third generation, 32-bit microprocessor and a 16-bit microcontroller, and application and a domain specific these are. For example, digital signal processing. And fourth generation, these are the real-time systems where the examples comes like a system on chip, and mobile internet devices, smartphone devices, all comes under the fourth generation. So depending on the complexity and the performance of the system, we are divided into small scale, medium scale and a large scale. The small scale embedded systems are simple in application, performance requires are not time critical, and they may have the operating system or may not be having the operating system. So examples are the electronic toys, remote controlling toys like cars and all are the example of a small scale embedded systems. In medium embedded systems, these are slightly complex in hardware and software systems. These are built with a 16 to 32-bit microprocessor or a controller, and these are contain the embedded operating system for functioning. Examples are the digital signal processing. And the third one is a large scale or a complex systems, we can say. These are the highly complex hardware and the softwares, and these are very critical application demanding on the high performance, built around the 32-bit or a 64-bit processor or the controller. Examples are the programmable logic devices like decoding, encoding media, cryptographic functioning implementation, all comes under these large scale systems. So based on the deterministic behavior, application of a real-time systems, these are the based on how it's going to behave in a real time. And next one is the based on triggering. Here in triggering, event triggering and a time triggering are there. Based on the time pulses, it's going to change the events. And next comes the application of embedded systems. So embedded systems are having the huge number of applications. Important domains are consumer electronics. In whatever the daily electronic devices are there, those electronic devices are having the embedded system like cameras, camcorders. And next is the household appliances, where televisions, washing machines, DVD players, these are the examples of the household application. In home automation and security system, we will be having the intruder detection alarm, air conditioner, automatic navigation. And it comes to the telecom, we will be having the telephone switches, cellular telephones. And in computer peripherals like printers, scanners, fax machines, and computer networking systems, we will be having network routes, switches, hubs, firewalls. And in healthcare, we have seen the ECG machines, EEG machines, scanners, all those machines are comes under the healthcare embedded systems. And in measurement and instrumentation, digital multimeter we use for checking the resistance, current, voltage, that multimeter, and digital CROs, logic analyzer systems, those are comes under the measurements and instrumentation. In banking and retail, we have seen the ATM, automatic teller machine, and currency counters, and point of sales. And next comes the what is the purpose of these embedded systems. So embedded systems are only mainly we have mentioned as data collection, storage or representation. So if the huge number of data is there in the form of text, voice, image, video or electrical signals or any other quantities, that data can be collected and stored somewhere. If that data is not necessary, we can erase them. The best example for this is the digital cameras, where we can take up pictures. If not needed, then we can delete that also. So next comes the data communication. So where the two mode of communication transmission between the two end of the users takes place. This is with respect to the wired also and wireless also. So if for a wireless, we are having the examples like Bluetooth, Zigbee, Wi-Fi, GPRS systems, and for a wired, we are having the so many examples like wired printers. Those are the communication types. And next, data processing, where the speech processing, audio processing, those all takes place. The example for this is the digital hearing aid. And next is the monitoring. So we use the monitoring like ECG monitoring, EEGs, and in labs we use the CROs, digital multimeter. Those are the monitoring embedded systems. Next comes the controlling. So where we need a controlling air conditioner to control the temperature of the room. Here we will be having the sensors and actuators. So which are sensors are connected to the input part of the system, and actuators are connected at the output port of the systems. And next then comes as the application specific, and mobile phones are the application specific embedded systems, and others you can list out anything for the purposes. Thank you.